This is a very important section, 10.1%, because percents are so important for so many different parts of a career or even just daily living. I hope that you'll find this video helpful, as I will start by describing and explaining a little bit more about what percent is, and then we'll look at some basic equation translation problems, percent change, which is an increase or decrease, and then a few other examples that seem to come up often. So to start with, let's talk for just a minute about what a percent is. The name gives it away, per cent per 100. So if you have a 23%, that's the same as 23 per 100. If you have a 7%, then 7 per 100 would look like this. Once you understand that a percent simply means per 100, you understand that you can write this 23 with 2 decimal places to get the 23 hundredths, or 0.23. 2 decimal places means that for 7%, I need a 0 placeholder. So 7% would be 0.07. But per cent, if we can remember that the cent means 100 out of 100, percent problems will make a lot more sense. Now there's 2 pieces that you want to know when you're translating an equation. When you're looking at the words for a percent problem, such as what percent of 12 is 89, or something of that nature, whenever you get to the word of, that means to multiply. And by the way, when you see the percent in that problem, it's often helpful to just change it to a decimal. So again, per 100, so how many hundredths? 132 percent, 132 per 100 we'd start with the 32, and if we always have 2 decimal places, then that decimal will go right here. So we'd have 1 and 32 hundredths. Here's an example. What is 12% of 9? The way that you can solve this problem every time is simply translating. When we get to a what, we'll put in our variable. When we get to an is or are, we'll change that to equals. A percent, such as 12%, 12 per 100th, or I'm sorry, 12 per 100, we could write that as a decimal, 12 hundredths. I'm going to put it in parentheses so that that decimal doesn't look like a multiplication symbol. Of always translates to multiply or times, and I can show multiplication by writing this next to each other rather than inserting an X. You see that if I insert an X for times, it could be confusing with the X variable. If I inserted a dot for times, it could be confused with the decimal. So it's often easiest to simply write this in parentheses. When I put this in my calculator, I get 1.08. So I could say, therefore, 1.08 is 12% of 9. Here's another example. 12 is what percent of 39? I'd encourage you to stop the video and try this problem on your own. Put a pause on the video and see if you can get the solution, and then watch my solution to see if it's the same. Here I'm just simply going to translate again. 12 equals X percent, so X times, so of is times 39. Here I need to use a little bit more work, which is solving an equation. To solve this equation for x, I'd have to get rid of the times 39, and we undo times 39 by dividing by 39. So I could get that x equals 12 divided by 39, which looks like this. Now this problem didn't specify where to round, so I'm going to round to 4 decimal places. If I round to 4 decimal places, I'm going to look at the 6 and see that this 9 makes the 6 come up. So it'd look like this, 0.3077. Well, the question asked what percent is 12 of 39. So I need to change this answer to a percent for my therefore. And when I change this to a percent, it's always 2 decimal places. Oh, let me write it correctly. Therefore, 12 is 30.77% of 39. And that's it. Notice that all we're doing is translating the words into an algebra equation and then solving for x. What number, so there's our x, is 7% of 91? 7%, if I make 2 decimal places, I'm going to have to add a placeholder. So x is 7% of 91. 7 hundredths times 91 gives us 6.37. Therefore, 6 and 37 hundredths is 7% of 91. So those are some basic translation problems. A lot of our word problems will require you to read a little bit further in. Here's an example, and this is a common problem where we've got a percent change. Easy formula, and I'd encourage you to write this down, that the percent change is going to equal the amount of change divided by the original amount. Now, this percent change comes up in a number of types of problems. It could come up with an increase or decrease in pay, or in cases of the flu, or in a tax rate. It could also come in a sale or in a price hike. So a percent change could be that the price has gone up over the last year for toilet paper. Or a percent decrease could be a sale at your favorite store where some of your favorite items might be on sale. So the percent decrease would represent how much of a change in the price was there. But all of these just fall in the category of a percent change, and you can use the same procedure for all of these problems. So let's try one of these. If you get a $3 raise from your $12 an hour pay, what percent increase is that? Well, first I need to know how much the change is, and that's given as the $3. And then the original amount was the $12. Oops, sorry, I'm writing that. Said it and then wrote it in differently. So 12. If I divide 3 divided by 12, I can get a decimal that can now be changed to a percent. So I could say, therefore, the $3 raise is a 25% increase. It's so helpful to be able to understand this type of problem when you read an advertisement or when you read a news article. Helps you really understand things much better. Here's another type of percent change, a tuition drop. Tuition has dropped from $250 to $212. What was the percent decrease? The percent change is going to be the amount of change. I'm going to use this triangle as a math symbol for change. It's a common symbol that we see for change. So this is the amount of change over the original amount. So you simply need to start by understanding which of these numbers was the original tuition and how much did it change. Well, the amount of change looks like it's 250 minus 12. Let me write that in. 250 minus 12, which is going to come to 238. I'm sorry, I'm not sure how I did that. 250 minus 212, not 12, right? So $38 difference. And then the original amount, do you see that the original amount is going to be the 250, not the 212, but the 250. Because if it's dropping from 250 to 212, the original tuition was the 250. If I divide 38 divided by 250, I get 0.152. I can change that to a percent by making 2 decimal places. Therefore, this is a 15 2/10% decrease. You always want to end the problem with a statement such as that, like a therefore statement. You could write the word therefore, or you could use this nifty math symbol, which means therefore. Here's another example. If your bill comes to $17.50, how much should you leave for a 20% tip? What this question is asking us is, what is 20% of $17.50? Now make sure you're understanding the question. It's not asking us a total. It's asking how much should we leave for a tip. So all I need to do is multiply 20% times $17.50, and I get that the tip amount should be $3.50. Therefore, leave a $3.50 tip. Excellent way to be able to calculate tips rather than trusting that what is stated on the receipt is accurate. This next question, where we're adding tax and tip, helps you understand. An entry question to this is, should we be taxed on the tip, or should we tip on the tax? And the answer is no to neither of those. So you want to make sure you're calculating the tax separate from the tip. So we want to calculate the tip off of the $17.50 only and not off of the tax added to that. Here's the best approach for this problem. Let's understand the problem that we want to take our $17.50 and we want to add the tax and the tip, right? Well, if we do this tax and tip added together first, it's going to make it a lot, it's going to shorten our process. Here's one other shortcut. Well, actually, you know what? Let me do the problem this long way first, and then we'll come back and I'm going to show you a really neat shortcut. So first I want to find what is 28.5% of the 1750, because that's going to tell us how much we add for tip and tax. X is 0.285 times 1750, and that comes to $4 and 0.9875. So I need to round up, it looks like, to 99 cents. But what this says is what is the total. So to get the total, I'll now need to add this I'll now need to add the $4.99 to the $17.50. So therefore the total is $22.49. How did I get the $22.49? I added the $17.50 to the $4.99. Now, if you want, you could go back and calculate the tip amount and then calculate the tax amount and add all three of those separately. But I find it a little easier to add the tax and tip together, 28.5%, and take that of the $17.50 just one time. But there is an even easier way where I don't have to go back and add, and here it is. If you recognize that you need to pay 100% of the bill plus 20% of the bill for tip plus 8 5/10% of the bill for tax, I could add these three together once to get 128.5% of 1750. So 2 decimal places, 128.5%, 2 decimal places will make that 1.285 times 1750. So that will be 22.49. The same answer we got the long way. But I really think this is the best approach, to just add a 1 to our tax and tip, our tax and our tip. So 1.285 times the 1750, so we can do it all in one swoop. Well, I hope that you found this video helpful. If you do have more questions, please send them my way. I'm happy to work out more videos for additional examples, or I'm happy to just talk through some of the concepts that you may find a little fuzzy. Let me know how I can help you continue to succeed, and thank you for the work you're doing to succeed and to learn this material.